dynamics.
So let's kind of explore that quantum mechanics, because this is quantum mechanics is just weird when you get right down to it.
It is. It's a mysterious area of science, and I think a lot of people are curious about it.
So I know there are people that talk about how quantum mechanics can get rid of causation, or seems to have things happen without a cause. What are some of the things in quantum mechanics that lead people to make statements like that?
One of the cleanest examples is radioactive decay. We know the properties of lots of atoms and the statistics associated with the group of atoms, but when it comes down to a particular atom, we don't have any math that describes when that atom will decay.
So the idea being, well, it's just sitting around there and it just decays without any cause.
Without a cause,
okay.
Yes. And so I think that is a mystery to some folks.
So, I mean, just kind of going deeper, it seems like most of quantum mechanics has this statistical nature.
Yes. Just
due to this, I'll kind of explore this a little bit, the superposition idea that things, at least in the mathematics we use, things are both like decayed and undecayed at the same time.
Right. You have, let's say, a particular particle in a lower state. This whole word of quantum mechanics, quantum just means small jump or packet or discrete difference in energy level. So if an atom goes from this level to that level with interaction of light, you have three waves interacting with each other.
Okay.
We don't know exactly when that will jump. We know statistically how it will behave with a group of atoms, but a particular atom interacting with light, we couldn't say that it will absorb or not absorb.
So just kind of as a practical measure standpoint, it sounds like when we're looking at thousands of atoms, we can predict very accurately what's going to happen. When we're looking at an individual atom, per se, with the quantum mechanics, we really don't know what's going to happen.
On a particular individual atom, yes. And we have everyday products. If anyone's ever come into your home with a laser thermometer and measured the air vents to see if your air conditioning is working, that's the statistical behavior of the hot atoms in that air vent. We know that very well, and we can tell you the temperature of the air coming through that vent. But a particular system, a particular atom, or a particular photon of light, there's no math to describe a quantum jump.
Okay. So let's kind of delve into that. So if we've got this atom that's, for all intents and purposes, just sitting there and spontaneously decays.
Correct.
For all intents and purposes, we have no idea the mechanism behind it, if you will.
Right.
There's no traceable cause, if you will.
Right.
I'm gathering people extrapolate that and say if quantum mechanics does that, perhaps universes just pop into existence in the same way. So they may have a beginning, a definable event, but there's no cause, if you will.
Right. This was a famous debate at Purdue between Alex Rosenberg and William Lane Craig, talking about if quantum mechanics has things that happen without a cause, then perhaps universes could happen without a cause.
So what do we do with that? Do we just say, well, yeah, things happen without a cause? That seems to be a big thing from a philosophical statement, that things that happen have a cause.
Yes.
That's how science works most
That's
of the
right,
time.
and that's a critical piece of Dr. Craig's argument. He says things that begin to exist have a cause. That's premise one. And if you can attack that premise, then his whole Kalam argument falls.
Yeah, well, it's not just his. That's
right.
It's a long-standing philosophical argument.
Causality, yes.
Right. So why is it that people seem willing to give up causality, or what is it that allows them to think causality is not that fundamental?
I think it's an improper extrapolation.
Okay.
Just because you don't know the cause or can't mathematically write out the cause of a nuclear decay does not mean there is not a cause. You see the disconnect? Just because you don't know the cause doesn't mean that there is no cause.
Okay.
And I think that's the jump they're making. They're saying because we don't know there's a cause or a particular cause of this atom's decay, there is no cause. I don't think that's a legitimate extrapolation.